So this is the rest of the video that is going to be on acceleration and distance. And if you see right here in the picture, the blue car is accelerating and its velocity is increasing each second because acceleration is positive and velocity is positive. So each second the velocity is going to get larger and larger because you take initial velocity and you add acceleration each time. So each second, so the velocity is increasing. An orange car has velocity in the positive direction and acceleration in the negative direction. So each second you add a negative number to a positive number, so the velocity is positive and the acceleration is negative, so you add the negative number and the velocity is decreasing. So you can see that this car is slowing down, the orange one, and the blue one is speeding up. So I'm going to continue with some practice questions on acceleration and distance and displacement. So here we're given that the initial velocity of the object is 4 meters per second. As always, I'm going to write down everything that is given. Acceleration is 3 meters per second squared. And the time that the object has traveled is 12 seconds. So time is 12 seconds. And they ask you about the displacement. So for the displacement, I need average velocity times the time, which means I need initial plus the final divided by 2 times the time. I don't know what the final velocity is. So to find the final velocity, I need to take initial velocity and add acceleration each second. So I have 4 plus 3 times 12, which is 36. 36 plus 4 gives me 40 meters per second. Now I'm going to plug it into the displacement or distance formula. So average velocity, initial is 4, final is 40, divided by 2 times the time, which is 12. So I have 22 times 12, which gives me 264 meters. I think you have enough information and you should be able to solve this question number 15 on your own. So I'm going to write down everything that is given, and you should pause it, write down everything is given as well, and then try to solve it and then watch my video. So I wrote everything that's given. You have initial velocity is from rest, and acceleration is 6 meters per second, and the distance is 90 meters. Now think about which formula you should use to solve this question, and pause it and try to solve it. So I hope you noticed that it is A and D, so acceleration and distance problem. So you could use the formula, but I'm going to derive it one more time in this video. So I have acceleration is change of the velocity, final minus initial, divided by the time, and the distance is average velocity, which is initial plus the final, divided by 2 times the time. And then I'm gonna solve for time and replace time in distance formula. So if I solve acceleration for time, I have change of the velocity, which is final minus initial divided by the acceleration. So now I'm gonna take this and plug it into the distance formula. So the distance is equal to the initial plus the final times final minus initial, and this one divided by 2, and this one is divided by acceleration. So this is your time. And in the previous video I mentioned that if you have A minus B, you should know this formula, and A plus B, that is the difference of the squares. It's A squared minus B squared. So I have here final plus initial and final minus initial. So what I can do is to write the final squared minus initial squared, or you can distribute and multiply to get this formula, and then divide by 2a, and that is equal to the distance. Now if I solve for the final velocity, I get the final velocity is equal to the square root of 2ad plus the initial velocity squared, and this is the DAF formula. So every time I have the distance and acceleration, I'm gonna use this DAF formula to solve for the final velocity. So now I'm gonna find the final velocity is equal to, and again, don't memorize the formulas, you have to know how to derive them. So the final velocity is equal to 2 times acceleration times the distance and plus initial velocity squared gives me 32.9 meters per second. So my final velocity is 32.9 meters per second, and they ask you how long did it take. So final velocity and how long. How long, I can use my the time formula that I found. So that's the change of the velocity divided by the acceleration. So I'm using this formula. Final is 32.9, initial is 0, and acceleration is 6. So the time is equal to 5.5 seconds. There are more questions online in our lessons for practice questions for initial velocity, final velocity, acceleration, distance, time, and that formula, how to derive that formula. So you should always derive that formula. But I'm gonna skip those questions for practice because I gave you enough practice to look at, and you should practice the other ones on your own and check your answers online. So what we're gonna do is the free fall. We're gonna start the free fall here. And gonna look at the questions, how to use what we know from the previous that we covered, how to solve the free fall questions. So an object is said to be the free fall when it has only force of gravity acting on it, and on Earth the acceleration due to gravity is 9.8. You see this in red. So acceleration due to gravity on Earth is going to be 9.8. And we're going to look at why it is 9.8. For now, you just have to remember that acceleration due to gravity on Earth is 9.8. And you see here, if objects dropped in the air, one has more air resistance than the other, so they will not land at the same time. But if they are dropped in the vacuum, because they have the same acceleration due to gravity, they both will reach at the ground at the same time. But if they dropped in the air, one of them will reach terminal velocity before the other one. So the feather reaches terminal velocity. What that means, terminal velocity? Terminal velocity means when the force acting down is the same as force equal up. So it reaches some velocity at which air resistance force is equal to the same as force of gravity, and it stops accelerating. But without air resistance, two objects will keep accelerating at the acceleration of 9.8 meters per second squared and reach the ground at the same time. So it doesn't depend on their mass or how big they are and how light they are, like anything, but only acceleration is the one that determines at what velocity they hit the ground and the height from which it's dropped, because the higher you drop the object from, the more time it takes to reach the ground, the higher the velocity, final velocity is going to be. So what we're going to look at is like number 21 question. If an object was let go 3 seconds ago, what is its speed in 3 seconds? And when I say let go, means initial velocity is 0. So if you let something go at 0 meters per second and it flies for 3 seconds, its velocity in 3 seconds is 30 meters per second, and I round my acceleration due to gravity to 10 meters per second squared. On AP exam, it doesn't matter whether you use 9.8 or 10 meters per second squared, so I'm always going to use 10 meters per second squared. So that looks like in 3 seconds, the velocity is 30 meters per second, because each second you add 10 meters per second. Each second, or acceleration, is 10 meters per second squared. So what is the speed? We answered that question. What distance did it travel? The distance is average velocity times the time. So the distance here is equal to average velocity. I have 0 and 30. Average is 15. And times the time gives me 45 meters. So for number 22, you see that an object was let go 4 seconds ago. So if an object was let go 4 seconds ago, its speed in 4 seconds is 40 meters per second. And how do I find it? Like, I know you understand it by now that it is 40 meters per second, but what I use is this formula. The final velocity is equal to initial velocity plus the acceleration times the time. So your final velocity in 4 seconds is equal to initial velocity 0, because it's not always going to be 0. In this case, it is 0. Acceleration due to gravity is 10. And don't call this number 10 as gravity. You call it acceleration due to gravity. And the time is 4 seconds. So that gives me the final velocity of 40 meters per second. What distance did it travel? So the distance is, again, average velocity times the time. And your initial velocity is 0 meters per second. Your final velocity is 40 meters per second. The average velocity is 20 meters per second. 4 seconds gives me 80 meters. And then what distance did it travel over the last second? Here's the tricky part. Over the last second. So if it was for 4 seconds, it has 1, 2, 3, 4 seconds. So the second before, the velocity was 30 meters per second. And then the last one was 40 meters per second. If I want to find the distance here, again, I have to use average velocity times the time formula. And average between 30 and 40 is 35. And the time is 1 second. So that is 35 meters. It traveled 35 meters over the last second. So here's one more question. If an object was let go 5 seconds ago, what is its speed? So here we know this is 50 meters per second. What distance did it travel over this time? So I have initial velocity is 0, final velocity is 50, average velocity is 25, and 25 times 5 seconds gives me 125 meters. Yes, I want you to be able to solve these questions in your head. Then what distance did it travel over the last second? So I'm going to draw 5 seconds. 1, 2, 3, 4, 5. So here velocity is 50 meters per second. Here velocity is 40 meters per second. So average velocity is 45 times 1 last second. So that gives me 45 meters. It traveled 45 meters over the last second. What distance did it travel over the last 2 seconds? So here's velocity was 30 meters per second. And I need to find the distance between these 2 seconds. So the average velocity is 40 times the time is 2 seconds. So that gives me 80 meters. So here is another question. What distance did the object, what speed of the object if it was let go 6 seconds ago? So here is going to be 60 meters per second. What distance did it travel over this time? Average velocity is 30 times the time 6 seconds gives me 180 meters. What distance did it travel over the first second? Here's a very interesting thing. I'm going to do over each one. So 1, 2, 3, 4. So here is the velocity 0 meters per second. Then you have 10 meters per second. Then you have 20 meters per second, 30 meters per second, and 40 meters per second. And then so on till 60. So what distance did it travel over the first second? The distance over the first second is 5 meters, because average velocity is 5 times time 1 second gives me 5 meters. What distance did it travel over the first 2 seconds? The distance over the first 2 seconds is average is 10, and times 2 gives me 20 meters. So over 1 second, the object travels 5 meters. Over the first 2 seconds, it travels 20 meters. What distance did the object travel over the first 3 seconds? So the average velocity is 15 times 3 gives me 45 meters. And then, and so on. So here they ask you, what distance did the object travel over the first second? So the answer is 5 meters. What distance did the object travel over the first 2 seconds? That was 20 meters. And that's the only one where it matches. What distance did it travel over 3 seconds? So that's going to be 45 meters. over the last second. So over the last second, I have the last one is 60 meters per second, and the one before is 50 meters per second. So if it is 60 and 50, the average is 55. 55 times 1 gives me 55 meters. So it travels 55 meters over one last second. What distance did it travel over the last 2 seconds? So the last 2 seconds, it's the 4, 5, and 5, 6. So it's the second 4, 5, and 6 seconds, right? So the velocity here is 40, the velocity here is 60, the average is 50, and it is last 2 seconds. So that is 100 meters. So over the last 2 seconds, 100 meters. What distance did the object travel over the 4th and the 5th second? So between the 4th and the 5th, I have 40 meters per second and 50 meters per second. The average is 45 times 1 second, because between 4 seconds and 5 seconds only 1 second. So that is 45 meters. And then what distance traveled between the 3rd and 5th? So 3, 4, 5. So 30 meters per second, 40 meters per second, 50 meters per second. And I need the distance traveled between these two. So average is 40 and times 2, the time 2 seconds, between 3 and 5, 2 seconds. So 40 times 2 gives me 80 meters. Here's one more question. How long will it take for an apple fallen from a 320 meter tall mountain to hit the ground? So I'm going to write wherever is given. They give me the distance it's going to travel. So the distance is 320 meters. I know initial velocity is 0. They didn't throw it, they just let it go. So 0 meters per second. And acceleration, it's a free fall. And little g is going to be our acceleration. So acceleration is 10 meters per second squared, acceleration due to gravity. And so what I see here is they give me the distance and they give me acceleration, and they ask me to find the final velocity. It's the formula. So my final velocity is equal to the square root of 2 acceleration, the distance, and the initial velocity squared. So that is 6,400, which is 80 meters per second. The next question is, what will be its velocity when it hits? Oh, they didn't ask you how long it takes, but the time how long it takes is the change of the velocity over the acceleration. So the final velocity minus initial velocity over the acceleration gives me 8 seconds. If they ask me about the time. Here's one more question. So the ball is rolled at the velocity of 12 meters per second. So this velocity is 12 meters per second. And it is 5 meters above the ground. So here I'm going to have two motions. One is horizontal and the other one is vertical. And horizontal motion has nothing to do with the vertical motion. I actually found for you a picture to show. So if you shoot a cannonball forward, its initial vertical velocity is 0. But its initial horizontal velocity is some velocity, v. I'm going to call it this one is vx and this one is vy. And horizontally, there's no force. If we neglect the air resistance, there's going to be no force acting on it. Because there's no force acting on it, the object or the cannonball is going to cover, or its velocity is not going to change. It's going to have constant horizontal velocity. But the vertical is not the same case. For the vertical motion, you have no velocity at first, but then you're accelerating. So then you have 10 meters per second, 20 meters per second, 30 meters per second, 40 meters per second, and 50 meters per second. So you're accelerating downward. And this is what makes projectile motion. So when they say that the velocity of an object is 12 meters per second when it's moving, when it was rolled off the table, that velocity of 12 meters per second is going to stay the same. What I need to figure out is what this velocity, the vertical velocity when it hits the ground. If I know this final velocity when it hits the ground, I can tell what time it took to hit the ground. And then it will depend on how high it was. And then I can figure out how far it lands. So at first I'm going to move at the vertical motion. For the vertical motion, I know the height or the distance is given of 5 meters, and I know acceleration due to gravity is given 10 meters per second squared. And I know that initial vertical velocity is 0 meters per second squared. It's the horizontal velocity that is 12 meters per second. So because I have the acceleration distance combination, I can't figure out this final velocity. It's the square root of 2 acceleration, distance, and initial velocity vertical squared. So that gives me final velocity of 10 meters per second. So it takes 1 second, so the time is change of the velocity over the acceleration. Final vertical velocity minus initial vertical velocity divided by the acceleration gives me 1 second. It takes 1 second for the object to hit the ground. Now I can calculate how far it landed. So I'm going to look at the horizontal velocity. So the horizontal distance is equal to the average velocity times the time. And that horizontal velocity doesn't change. Horizontal velocity is 12. So it was 12 and it will stay 12. So it's just 12. And the time is 1 second. So it will land 12 meters away from the table. Here's another question we should look at. A ball is thrown at 12 meters per second, so initial velocity here is 12 meters per second, and the angle with the horizontal is 60 degrees. So the angle is 60 degrees. And we want to find out how high will it go and how far will it land. So for this, I need horizontal component of the vector and the vertical component of the vector. So I'm going to redraw it right here. So here is my 12 meters per second. And then I need horizontal component and the vertical component. And if you remember from the previous lessons, if this is 12 meters per second, then y, or the opposite of the angle, is going to be with the sine. So this one is going to be 12 sine 60, and this will be 12 cosine 60. So 12 sine 60 is 10.4 meters per second, and 12 cosine 60 is 6 meters per second. Now, the ball is going to move in the projectile motion and lands. If it has a vertical velocity of 10.4 meters per second, so let's say I have 10 meters per second. The deceleration for something thrown upward 10 meters per second is still 10 meters per second squared. So each second I'm losing 10 meters per second. So if it's 10 meters per second in 1 second, I'm going to lose the velocity, it's going to stop. If it's 20 meters per second in 2 seconds, I'm going to lose the velocity. If it's 30 meters per second in 3 seconds, I'm going to lose the velocity. But I don't have 10 or 20 or 30, I have 10.4. So if I have 10.4 meters per second, it will take me 1.04 seconds to get to the top, and another 1.4 seconds, 0.04 seconds to get to the bottom. So this one is 208 seconds before it hits the ground. So if I want to find out how far it lands, I need to take the distance formula, and it is average velocity times the time. Average velocity in horizontal, which doesn't change, so your horizontal velocity is 6 meters per second and it doesn't change, times the time, which is 208. So that gives me 1248 meters. So that's how far it lands. And then I want to know how high into the air it will go. So I want to find out this distance. And this distance, the height, again, is average velocity times the time. The time it takes to go to the top is 1.04 seconds. And the average velocity between the top and the bottom, this is my initial velocity, vertical, right? This is my vertical initial velocity. And the final vertical velocity is 0 meters per second. So the average velocity is 5.2 meters per second times 1.04 seconds, and that will give me 5.4 meters. So it will rise 5.4 meters and it will land 12.48 meters away. Here's one more type of this type of questions. So an object was thrown in a projectile motion, and they tell you that the angle is 60 degrees. So the angle is 60 degrees. And it lands in 8 seconds. So in 8 seconds, it lands on the ground. That means to the top, it took 4 seconds, and to the bottom, 4 seconds. So to get to the top, 4 seconds, to fall down, 4 seconds. So if to get to the top is 4 seconds, then your initial vertical velocity must be 40 meters per second, because it stops in 4 seconds to go vertically. So the distance up, this distance is average velocity times the time. Average velocity between 40 and vertical is 0 at the end on the top is 20. Time to lose 40 meters per second, losing 10 meters per second each second, is 4 seconds. And the distance will give you 80 meters up. So the ball is going to rise 80, or an object is going to rise 80 meters up. Now, it takes 8 seconds to fall on the ground. 8 seconds to fall on the ground. So I need horizontal velocity for horizontal motion. And because I know that your vertical velocity is 40, I know that this is equal to, so if this is initial velocity, this is equal to initial velocity sine 60. So from here, I can figure out initial velocity is 40 over sine 60. So initial velocity is equal to 46.2 meters per second. So that means this initial velocity right here is 46.2 meters per second. Then adjacent component is v sub 0 cosine 60. So this was your v sub 0, right? This is initial velocity. And then my vx, this is your vx. So vx is equal to v sub 0 cosine of 60 is 1/2. So that gives me 23.1 meters per second. So it's 1/2 of this number, right? Now, if I look for the distance traveled here, the distance is equal to average velocity times the time. Horizontal velocity does not change, so it's just 23.1, and the time is 8 seconds. That gives me 184.8 meters. So it will land 184.8 meters away.